So I wanted to do an open-ended type example. We will see these fairly often. There's one on this week's worksheet. There's typically one on the test on the final exam, you know. So, and these are a little bit confusing for people at first because there's lots of different possible answers. And so your answer may be different than your neighbor's answer. They may be both the same. The reason is we're asking you to draw a picture. We're not asking you to write down any kind of formula for this. We're just asking you to draw a picture that satisfies a list of conditions. And I just listed as many as fit on my board. One of the conditions, it says the very first thing is graph a function f of x. So I'm going to graph the function. It better have, what do I have to do? Okay, it does tell me. Okay, it better be a function. So your answer, when you're done, just to make sure that you've satisfied the question, by the way, I'm going to go through, and I'll go back through all of it. But I also want to go through and, like, in my head, you know, put the vertical line test in there and make sure that I don't have some extra pieces laying around and it's not really a function. All right, so the domain is all reals except for the point at 2. Now, I don't know what's going on at the point at 2, so I'll just keep that in the back of my mind. If I want, I can read through it and figure it out, but I like to just read through each bit first. And let's see. The limit as x goes to negative infinity of f of x equals negative 1. So that's going to tell me that I have a horizontal asymptote on the left-hand side. So I'm going to draw in my horizontal asymptote. I don't know how long it needs to be or where it needs to go. I know that my function is going to be going, it could be going this way, it could be going this way right now, but I haven't figured it out yet. I could be wiggling back and forth, but as I go out this direction, I better be, let's see, I'll put that there so we can see that that's actually part of my function. I better be going towards that line. Now the next thing it tells me that f is increasing. So that's actually going to tell me more. Now I know I can't be going like this, and I can't be going little squiggle. I actually have to have a function that's increasing, and it has to be increasing all the way to negative 2. Now it doesn't tell me, let me, because I could just do this, right? But maybe that's what I want to do. So I can do it. Does it say anything else? The next thing it tells me is that the limit doesn't exist. Okay, so this is a full limit. It doesn't tell me from the left or the right. It's just the full limit doesn't exist. So I kind of have plenty of choices there, right? I could make it an asymptote, but I have to be careful because that point negative 2 is still in my domain, so it still has to be defined there. But I could make it an asymptote, make it go off one direction or the other, or I could make it jump. Whatever. So I have a choice, or I can make it wiggle infinitely. I have a choice. And because the problem didn't tell me anything else about negative 2, it didn't tell me the left-hand limit or the right-hand limit or whatever, I can just choose whatever I want as long as the full limit doesn't exist there. And as long as my point is defined, because the point at negative 2 rather, is in the domain. So here, let's just make it. Let's just make it like that. Okay, fine. This limit definitely doesn't exist. Now the next piece of information I have, it doesn't ask me for anything between negative 2 and 2, so I can put whatever I want there, but I have to put stuff there because all the points are in the domain except for the point at 2. So I can't just leave it blank even though it didn't tell me anything. I can put whatever, but I can put whatever I want. So I can put straight line, I can put twisty, turny, curly cues as long as it's a function. The next piece of information I have is that I have an asymptote at 2. A vertical asymptote at 2. So I'm going to label it. And it actually also tells me, because this is not a left-hand or a right-hand limit, this is the full limit, so it's going to infinity on both sides. So I can just make this guy go to infinity on both sides. Now, all right, now what about the rest? Well, the rest actually has to decrease, right? Because it's going to tell me that f is decreasing from 2 on, so the function is going down, and in fact, as it's going down so far as going off to infinity, it's not even, it doesn't even have a horizontal asymptote, so I can just sort of make that go down. Okay, so this is a function that satisfies all of these, and we can go back through them. Okay, yeah, clearly it's a function because I have, there's no double defined points. Every point is defined except for the point at x equals 2. I've got my horizontal asymptote increasing up to something that has a limit that doesn't exist at this point. Here I'm going both sides to positive infinity, then I'm decreasing down to negative infinity. That looks good. But you guys, there's many, many other ways I could have drawn this, and they would also have been correct.